Let us now do a few problems. Here the question is find voltage V0. So this is the voltage V0. Here we have the mutual inductance J1. Okay. Now we can use the normal circuit analysis techniques here, only that additionally we have the mutual inductance. First we will assign the currents because mesh analysis is the best procedure here. So I1 and I2 are the currents in the first and the second loops. So here you are going to get 120 angle 45 degree volt is equal to 4 times I1 plus J8 times I1. Then what about the mutually induced voltage? Here I2 is flowing into the dotted terminal here. So here the dotted terminal will be positive. So since we are going in this direction, the positive polarity we are encountering first. So the mutual inductance term will be positive. The mutual inductance is J1, but J1 into I2 we have to write. Okay. Plus J1 into I2. This is the first equation. Now the second equation, we are going in the clockwise direction. First the resistance, the voltage across resistance will be, this is KVL in loop 1. Now we are finding out the KVL in loop 2. So 10 times I2 plus the self inductance is J1. It is flowing into positive, going in the same direction as the current. So what we are going to get I2. Now what about the mutual inductance term? Here the current is going into the dotted terminal in this coil. So at the dotted terminal you will get positive. So when we are going in this direction, first we are getting the positive. So this will also be positive. The mutual induced voltage is also positive in the direction that we are going. Okay. So J1 times I1. So this is equal to 0. We have the second equation. So now we have two equations, two variables. You can write in matrix form, find out I1 and I2, and V0 will be simply 10 times I2. Okay. You can do the matrix form. Here I will do the simpler form, which is from this equation you can get I1 in terms of I2, right. So I1 will be equal to minus 10 plus J5 I2 by J. And this you can write as minus 5 plus J10 I2. This if you substitute in equation 1, what will you get? 120 angle 45 degrees is equal to I2 you can take out common, 4 plus J8 times I1, instead of I1 you will write minus 5 plus J10, I2 is anyways outside, plus J1. I2 you will get as approximately 1.2 angle minus 45 degrees. Okay. So therefore the output voltage V0 you are going to get 10 times I2, which is 12 angle minus 45 degree volt. Okay. So this is how you have to write the equations when there is a mutual inductance in the question. The next question we have, find input impedance given Z1, Z2 and ZL. Z1, Z2 and ZL are given in the circuit. Okay. So now what is meant by the input impedance? Input impedance is always seen through the input terminals, right. Wherever the source is there, that side will be the input. So we have to now find Z input like this. So we will see how to do that. We have in fact derived something similar already, right. So in that case what happened? Z1, whatever is in the primary side, Z1 will be as it is, Z1 plus something else. What else? The self inductance of the primary coil will also come here as well. So this is already given as J20. Reactance is already given, not the inductance and frequency. Okay. Next, what about the other rest of the part is going to be, in the numerator you have omega m whole square divided by what are all the impedances present here. We just add them. They are all in series. So what are the impedances present? Z2, ZL and the self inductance as well. So here you have divided by Z2 plus ZL plus J omega L2, but this is given as J40 and this omega m This is given as J5. Okay, J omega m is J5. So omega m will simply be 5. Okay, so you can substitute. What you're going to get, Z1 is given as 60 minus J100 plus J20 is the self-inductance plus omega m is whole square is 5 square divided by Z2 is 30 plus J40, ZL is given as 80 plus J60 plus J40. So this you can simplify. I will write the final expression 60.09 minus J80.11, or in terms of the magnitude and phase you're going to get 100.14 angle minus 53.1 degrees.